Awesome. Yes. Are we ready? We have the Jefferson Yes. So we do still need someone to take minutes, ideally in the Etherpad. Sean Turner, if we need someone to take minutes, ideally in an Etherpad. Or another TLS chair. Like actually, it's an intro requirement, isn't it? To jump in. Can you do it for us, Sean? Can you take minutes for us? Sure. Yeah. All right. So it's time. Welcome back from lunch. This is Saag. I'm Ben, and back here is next to me. So got the note well. You've probably seen it a bunch. If you haven't, note well. We've got our agenda up here. We do the usual working group reports. We got most of those in email, if not all of them. I didn't finish double checking. We've got a few talks and then the open mic. Does anyone want to bash the agenda? All right, let's see if we can blaze through the working group reports. So ACE, I think we got ACE, Acme, Curdle. Do we see Curdle? Call me. I guess Curdle wasn't meeting anyway. Does anyone want to come up and give the? They did send. Okay, I'm sorry, I missed it. Dots.
I didn't send it. We're meeting in the next session. Please do join us. We're quite close on all the informational documents. Moving forward, they're either in working group last call or ready to be sent to the ISG. And on the 2 protocol drafts, we're going to working group last call, both of them, one for the second time and one for the first time. So we're making good progress.
Cool. EMU, I believe we saw. I2NSF, I just forwarded on because we got Unicast. IPSecMe, we got Kitten, we got MLS, we just got lamps.
We didn't meet yet.
And you don't want to predict the hot topics? Lamps will meet later this week. Mile, I Oh, yes, Smile we saw, OAuth we saw, SACM, yes, Dispatch.
So for LAMPS, the working group was rechartered last week. We're getting started on the new work. Not much to say. The old work is either in the RC editor queue or with the ISG.
Thank you, Russ. Maybe we say second. I said second. Suit we saw, Teak we saw, TLS we saw, Bind.
I don't think we sent anything. Leif, meeting on tomorrow, last session. Most of the core documents are on their way out of ISG review, so we're getting done.
Trans. We discussed the last 6 items of 6962 bis. 3 of them were AD review items, and they will be resolved. We will get text shortly and send it back. 3 other minor items will either get text or get ignored. We had the thread document that's still sort of deadlocked. We'll break the deadlock once again and see if we publish or not. And all other work we deem to either have to spin up a new working group or see if it falls within publication if we're still open, but we're trying to close the working group.
And it sounds like we're going to do 6962 biz still as experimental.
So yes, there was no more objections to going to experimental for the biz document.
Thank you. And we've got, actually, we even already got some related working group reports on the list, so thank you for those. And the list on the slide might also be incomplete. If there's anybody who thinks there was something security relevant that you want to talk about, now's a great time.
Yeah, video for Deutsche Telekom. I wonder, you have Cider on the list, which essentially is dead for a year. And the interesting thing that happened with relevance there obviously has gone under the radar for security purposes. And I wonder that the Cider Ops is not on your radar, where the operational use of the stuff that came out of Cider is happening. And I wonder whether that is worth your attention.
Certainly worth looking at to see if it is worth our attention, so thanks. And my client looks pretty empty, so I guess we should move on to the BOFs, of which we didn't really have security. Oh, go ahead, Sam.
Sorry, make an announcement from an external organization. W3C is organizing a short workshop in September on permissions and user consent, how to ask the user for consent to use rich features and devices. If anyone's interested, we have a call for participation up on our website.
Cool. Thanks. Right, so the BOF schedule this time around was pretty sparse from our point of view. So I believe we can go on to the
Paul Hoffman, chair of DRIU BOF, which is meeting in the next session. So for those of you who have not been following DOE and such like that, one of the things that's come up is that currently with DHCP, you connect and it says, here are the IP addresses of your DNS resolver, and those are always over port 53. For a few years, we've had DNS over TLS, which runs on a different port, but there's really no way for DHCP to tell you that. So one of the things that DRIU will be doing is how do you do that, or how do you get DOE? But the other thing is, let's say that you get 2 things back from DHCP. One that says, here's a plain port 53 server, and here's an 853 server, which has some encryption, privacy, and such like that. How do you rank them? So the DRIU BOF, which is in the next session, is basically about how do we start thinking about it. It's not a working group forming BOF. We have a couple of drafts, but nothing big. But if you're concerned with these kinds of things like you know, what happens here? You have two different trust anchors. You've got DNSSEC and you've got the Web PKI and such like that. Come to the BOF.
Thanks, Paul. That's a good point. All right, so we can go to the presentations. And I guess I only updated the first agenda and not the slide. So sorry, David, but Apostol and David, you want to come up? Yeah.
Oh yeah, sorry about that. Apostol sent me the slide, so I assumed it was him.
No big deal. No, it's both of them.
So this is a joint presentation with
Give them the-
from this.
Would you like this?
Eat the mic.
And so I'm going to
Like,
raise it.
take it out of the stand or raise the stand or something.
Halfway down, there's an adjusting.
Okay.
They're all correct.
Pop it out. How many people here when you're AV Club in school?
Can you hear me? So I think that was the problem all along. Well, so it works, so I'll just hold it. I'm David McGrew from Cisco. This is a joint presentation with Apostle Voslev from NIST, who will be taking over about 5 minutes into the presentation. We're going to be presenting to you today on something called the Automated Crypto Validation Protocol. So this is joint work between our organizations and a bunch of other people. So let me give you some background. And you might be already familiar with this if you work with cryptography. But I want to talk about cryptographic modules and their validation. So a cryptographic module is an encapsulation of all the functionality you need to do to actually successfully do cryptography: encryption, authentication, digital signatures, key management, entropy, all the ancillary functions, all that stuff. You know, it's encapsulated in a module, right? So if you want to do cryptography, you're going to need that. And if you're either producing one of these modules or you're using one, you want to either gain an assurance that it was correctly implemented, or you want to provide an assurance that it was correctly implemented, right? So, you know, testing the correctness of this thing is what's done in validation. So before you validate it, you have to actually know what it implements, right? So the validation process consists of something like a set of known answer tests that you can provide to it. A set of, you know, the known answer test consists of a query and a response. And then there's, you know, randomized tests. And if there's a randomized algorithm, then testing it is a little bit more involved. The most widely known validation program is FIPS 140, which NIST runs on behalf of the US government. And so if you've ever implemented a crypto module, there's a good chance you've participated in the FIPS 140 program with their crypto module validation program. And they have a process for doing what I just described that's essentially manual, right? That there is, the implementer provides a PDF file that itemizes the algorithms and parameters and so on. A lab acting as an intermediary between the vendor and NIST will provide a set of test cases as use text files. And then the implementer maps these into the crypto module and gets a set of outputs, and then you iterate on that until all your outputs are correct, right? So I have a link. If you've never seen this before, you can click on the link once you grab the slides and look at the certificate for OpenSSL on SUSE Linux, just as a nice random example. So what problem are we trying to solve, right? If this validation program exists already, you know, why do we need anything different? Well, it's because of the delay, the lag between when you're done implementing a crypto module and when it can actually come out the end of this process, right? Because there's so many manual steps that it typically takes a long time. And so, you know, speaking as a vendor, the last thing I want to do is force my customer to choose between running a validated crypto module and running a patched crypto module, right? So if either there's a software update or a bug fix or whatever, you know, that no user should ever have to make that choice, right? So we want to narrow down the time from when a module is, you know, actually built and when it's actually validated. So we want to shorten that test cycle. And, you know, there are other considerations as well, such as, CMVP run by NIST is you know, a big substantial validation program that's really useful. But it would be nice if it were really easy to do a validation, then more organizations could be actually performing these validations, other governments, other third parties. And it's nice to imagine a world where there's more validation and assessment of crypto modules going on. So, but what we don't want to have is like every organization has their own processes, procedures, and interfaces for validating modules, and that would become, you know, unscalable from the point of view of an open source implementation of a crypto module or a vendor of a crypto module. So Apostle, do you want to come on up and take over? So he's an actual expert on CMVP, and he can speak to this in more authority.
Okay, thanks, David. So about 2 years ago, we reached out to the industry, and we've heard many of these complaints. There are others too. We don't have the time to go through the litany of concerns with this program. But we reached out to the industry and said, all right, why don't you come and work with us on rethinking how we run the validation program and build a new one that fits all of our purposes and serves all of our needs. And we started the working group. We are meeting bi-weekly, and we think about how we should rebuild the program, and not just think about it, but we're working on it. This is a big effort. It covers not just the algorithms, it covers the module testing as well. We're trying to even solve problems that currently the program doesn't do. For example, how to validate cryptography in the cloud environment. And the goal of our effort is not just to improve the speed of validations, but also to improve the depth and coverage of testing. We want to improve our testing methodologies to the level of technology today. Because let's face it, some of these testing methodologies that we have were created many, many years ago, and since then, technology obviously has moved to a totally new level. So where are we today? We have a bunch of working areas within the working group on improving the crypto validation programs. Some of them are related to, one of them is related to improving the algorithm testing program, others is for module testing, cloud, etc., etc. The focus of the conversation today is algorithm testing. And so, as David said, it's a collaborative effort. We have been working on automating the algorithm testing, developing a protocol for automating the algorithm testing. It's an idea that originated with David several years ago, I assume, and including a prototype. I remember David participating in the very first meeting of our working group, and that's where our conversation on this thing started. The effort now is being led by Barry Fussell from Cisco. He is also in the audience, and he will be talking to us later this evening with our show and tell on ACBP, much more detailed dive in. We're currently working on the 5th iteration of the protocol. We've been at it for a while. We have stood up a demo server actually that implements some of these things. It has a good README on GitHub, in fact, which provides a ton of useful information about what it does and how to get to work with it, what kind of access, credentials for access you need, and all kinds of stuff. We're currently covering about 90 plus algorithms and modes. Believe it or not, there's this many algorithms that on the approved list of NIST. In fact, the set of algorithms, the approved list of algorithms is even bigger, but we only have testing for so many at the moment. We are targeting releasing version 1.0 in this fall, actually. Our spec is already in a kind of an RSC format. We know it's not perfect, but it's good enough because at least there are 2 independent client implementations from scratch implemented based on it. So we know it's a workable specification. We also have a client, open client implementation provided by Cisco. It's on GitHub. You can take it and use it and jumpstart your experience with HCPP that way. So as I said in the beginning, speed is not the only problem we're solving with the validation. We're trying to improve our testing. And currently we are planning some future enhancements along these lines. One is a project of interest we're collaborating with is the project WitchyProof at Google. They have an interesting approach to testing cryptography, much deeper testing based on known attacks. We're collaborating with the Hackle project, which is a sort of a joint project between INRIA in Paris and Microsoft Research. So we're trying to see whether we can leverage the power of some of the formal verification of crypto within our validation program. We are trying to test even more from the approved list of algorithms, and that's what we're collaborating with Japan to provide testing on 856B key establishment primitives. The message here is not to give you an exhaustive list of all the future enhancements, but to simply say that we are open to learning and using good ideas that you may have about how to do testing better, crypto testing better. And if you have such ideas, please come talk to us. We are open for business, so to say. Very briefly about the features of the protocol. This slide is deliberately vague. I'm not going to go into any details of the protocol. Again, we have a show and tell tonight. We'll go much deeper into details. But as any protocol, it provides a transport, an encoding, and message format, and sets a particular set of message exchanges. It works over the internet and enables discovery of the capability of the module being tested. And depending on that, it generates corresponding tests. It provides a standard communication protocol such that implementers of crypto technology can use the same protocol to talk to various validation programs. We know we're running one of these validation programs. We know that there's interest in testing crypto in other parts of the world. A lot of things are happening in Europe, Asia, other places. We also know of private sector organizations that are interested in using validated cryptography. For example, the financial services industry, there is a PCI testing and all that kind of stuff. So we see a lot of possibilities where this protocol could be used. And of course, the structure of the protocol is quite flexible. You can add tests for new algorithms. You can add new tests for existing algorithms, and you can change the protocol features without changing the underlying algorithm tests. So in a nutshell, that's the protocol. So why do you do ACVP with IETF? Well, we think it makes a lot of sense. For one, we at NIST believe that openness and transparency of crypto standards and validation methodologies are necessary for acceptance. As you know, it's not enough to have a theoretically secure algorithm. It's important to know whether it's implemented correctly and robustly. And so that's why the validation
specifically HKDF, and the SIV, synthetic IV operations mode. So if you look outside of NIST validated crypto, there's a whole world out there.
Right. We recognize that we'll only cover a portion of what's out there in terms of crypto technology. And what I was saying before is that we are establishing a foundation for how to do crypto testing. And we are providing an extensible foundation for that matter. We have a protocol that can be extended to cover other algorithms that currently are not on the NIST approved list, and it's not likely that they'll ever be. However, there are interests in other places about those algorithms. And in addition to that, we're going to publish the code of the server we have developed so that you can stand up your own validation server and extend it for the algorithms that are of interest to you. Or some of the validation authorities that you are facing, they could do that too. I'm talking to a number of European countries and some Asian countries where there's an interest in hosting such a server. And obviously they will be supporting different sets of algorithms, not the NIST set of algorithms. So that's how I see things evolving. The key would be to use a similar protocol such that if you have a module that you want to validate in two different locales, you could use at least the same protocol. And on top of that, if you have an overlapping set of algorithms, it sure be nice to have the same kind of testing for the same algorithm regardless of the place where you go, right? So that's really what we're saying.
Okay. Thank you.
Yeah, if I could add really quickly, I would love to see the algorithms you'd mentioned added into the ACVP as, you know, things that could be tested.
Right.
Totally agree.
Chris, a quick question on the collaboration that you have mentioned with WitchProof. Are you working on, for example, adopting their test vector format or working with them to improve their test vector format, or what is the ultimate goal there?
Well, actually, they agreed to modify their test vectors to match the JSON formats of ACVP. So the plan is that once we roll out 1.0, we're going to integrate their library into our server and start generating their test vectors for testing. So that's how we see this evolving. We've been talking to them for close to a year, but it's hard to make progress on this front until we set up the foundation with what we already have. And,
Sure.
and we're close to getting there.
Okay, thank you.
Yeah.
So Martin Thompson, I've been looking on your website, looking for the specs, and I've been unsuccessful. I looked on GitHub. I found the source of the specs. Are they up on the web in a more accessible format?
What do you mean you're not? I mean, they should be
you look in-
available.
I can find the source of the HTML for various things, but I couldn't actually find anywhere that would render it without actually kind of raw.
We have artifacts folder. Have you checked the artifacts folder?
Okay, so I have to download it. Okay, fine. Thank you.
Yeah.
All right. Thanks. I'm still on video. It's really interesting.
Not always. So I hope you don't pull the plug on me as well.
That's how good you are.
Okay, next slide. So apologies to Melinda, the slide numbers are really weird, but there you go. Oh yeah, thanks. Click to us. So the TLDR here is that if you talk to a mail server in Ireland back earlier this year, that's listening on port 25 and is doing some crypto on other ports, maybe 443, IMAP, whatever, or SSH, then the probability that that same server host key is on some other IP address in Ireland was 53%, which seemed a bit high, and so it turned out. So basically, I've been doing some kind of scanning to try and play around and see if I can understand this better. And essentially, what we can do is look at a scan population and collect together all the IP addresses that have some key in common, and that forms a cluster. And basically, when you do that, you see every possible combination of things being reused, except I still haven't ever seen anybody use an SSH host key for TLS. But every other combination you do see. So port 25 on one host is 443 on another, et cetera, et cetera. So there's lots of possible causes for this. They're not all bad. So multi-homed hosts is one because we're only scanning IP addresses. So, you know, not all causes of this are bad. When I create these clusters of IP addresses that seem to have some keys in common, it looks like about 30% of them might be, look very much like multi-homed hosts, but 30% are possibly, and 30% definitely not. Because, for example, there might be more than one AS involved. So you can make little pictures like this, where the nodes represent the IP addresses, the lines represent the key being shared between the two IP addresses on some port, with different colors for the different port numbers. And then we'll see what the pictures start to look like. So again, not all key reuses are bad, but some could be. Clearly, if you get one of these keys, you could masquerade as any of the other hosts in the cluster for something. And if they're using RSA key transport, it's worse. It could be that the risk increases faster than linear with cluster size. It seems to me that that's the case. And this isn't particularly new. There's lots of related work on scanning of keys for SSH and TLS and others. Maybe what's a little bit new here is just the scale of the scans being kind of small country-sized and the clustering. So what I do, basically use ZMap and ZGrab in those 10 countries. Store the usual metadata, did some analysis code to kind of try and see where the clusters are, and do it slowly and be kind of ethically nice and so on. And again, it's only port 25 listeners that I'm looking at. So they listen on 25 and then I look at the other ports. So they're all mail servers. So what does it look like? So it looks like this a bit. In this case, there's a little cluster in Ireland. 3 hosts sharing an SSH host key in two different ASs. And the SMTP banners don't look like each other, like anything to do with each other. So that looks like somebody's SSH host key is in more than one place and they don't want it, which is not that uncommon. It's uncommon, but not that uncommon. This one is another cluster from Ireland, all using RSA key transport. It's a 1024-bit RSA key. It's a product vendor who ships with a demonstration key pair as part of their product. And they do document, like halfway down a 1,000-yard-long web page, how to kind of replace that. And in actual fact, this particular key was being used in the live MX of a place to which you would send security incident reports, which is a bit sad. But I contacted the vendor, and in that case, they said, yeah, we're actually going to go and fix this. So it'd be nice to see if they do. I'm sure they will, but whether people deploy the fix would be an interesting thing to check. This is just another cluster which has a mixture of kind of web and kind of mail keys. The only other thing that's interesting with this one is I had a November scan and one in March, and 2 IP addresses got taken away and 1 got added to this cluster in that time. So things evolve. This one is this looks like a kind of UK-based mobile application developer consultancy type company, and they basically are using a large kind of hosting company to host a bunch of things with this kind of amount of key sharing. The blue colors are mail, the orangey colors are kind of port 443. And it looks for lots of different SMTP banners. So this is for lots of different people. This one is from Slovenia. It's just like a prettier picture. If you look through some of the metadata for this, it looks like the hosting tools may be at fault. So this is like a whole bunch of things that people are hiring hosters to do. The hosters are splitting up virtual machines in various ways. If you look at the support for it, if you look at the names that are seen here in the metadata, it looks like some of those tools make it too easy for keys to be copied over into new virtual machines or not gotten rid of. And somehow you get this, which is kind of weird looking. And it doesn't look like something you would design if you were going to set out to design something. All right, notice this one. Again, this one is from Singapore. This is my favorite one. This is from Finland. So this, again, it's another mobile consultancy company. The black there is SSH keys being shared. The other colors I mentioned earlier. And in this case, there's one SSH host key that's seen 46 times here and 14 times in Portugal in a university for, again, some weird reason. So again, just to go through this quickly, we have some numeric results. If you look at the link at the top of the slide deck has a copy to the preprint. There's not that much of interest here to talk about now, but other than the number there at the bottom, the HARC, that's the percentage of hosts who are using keys from those that do some crypto in a particular scan. So you can see it's like 70%, which seems very high. The other interesting thing there is if you look at the max cluster sizes for the Ireland scan in 2018, there's 1,991 IP addresses all behind one single wildcard cert. And that key also is seen in Singapore, as it turns out. So some of these clusters are quite big. And there's some more results for different countries. The cluster size distribution is kind of as you'd expect. There's an awful lot of size 2 clusters, which probably is some okay type of mirroring or a host with 2 IP addresses. But then you get these very large ones and a bunch in between. You can check how does this evolve over time. So I have scans from November 17 and from spring this year for Ireland. And basically every possible change that you could imagine tends to happen. So if you look here, we get 168 clusters disappear, 700 appear, a few other odd cases. And then there's the kind of really complicated cases where, in fact, if you look at this one, the middle and the bottom there is a case where 2 clusters evolve into 3 clusters later on. Now, if there was any case where if you hire a new VPS and you had a chance to look at the disk and possibly extract a key that somebody else once used, this might become pretty sad. We can look across the 10 countries, as I did. So I had scanned 10 different little small countries, and basically you find keys in common between every single pair of possible things, even for Namibia, which is really small. And these look like that. If you take away some of these are also kind of reasonable. There's a bunch of New Zealand and Singapore ones where it could be somebody who's just trying to get around latency by having a host in 2 different places that it's otherwise the same. That might be okay. The ones that are more than 2 nodes look like this. And basically they're all kind of fully connected, pretty much graphs, which kind of smells like hard-coded keys or wildcard certs that are being used in many different countries. There's like 101 of them on that. I've gone through about half of them to see what they are. And there's various kinds of shipping with hard-coded keys going on from a whole set of different vendors who I'm trying to contact, but it's kind of slow. Just take a couple of examples. So this again is the same one I showed earlier. This is the product that ships with the demonstration key. And that again turns up in all sorts of countries for a whole bunch of IP addresses. This one here is another SSH host key one with Ireland, Estonia, and Portugal. Turned out here I actually have the private key involved because I have a VPS that I started using in 2013. And when I found the IP address of that in the data set, I went back and looked, and the SSH host key file was from 2012. So again, this was, I think the bug here is more hosting tools, where when they spin up a new VPS, if they see SSH key pairs for RSA and DSA, at that point they knew to throw them away. But when we added this lovely new algorithm, the hosting tool didn't know to throw that one away, so I inherited a ECDSA key. And that seems kind of common, and it's maybe yet another reason not to add new algorithms too much. This one is a piece of open source software that's intended for developers. This is a kind of a thing to get developers to kind of get started really quickly on developing the thing it's for. And again, ships with a hard-coded key, and it looks like it's being shipped as is not the intent, and also possibly built into other packages that are more popular, which I haven't fully verified yet, so I won't say what package. And again, I contacted them and they said, oh, we'd love to change that, and we might sometime. So again, these are the confirmed causes, the SSH host key regeneration and virtualization. That seems to be a mistake that happens over and over. There seem to be different generations of it. Hard-coded keys is clearly a thing that's still going on a lot. And amusingly, there are some vendors who release a 1024-bit hard-coded key, and then later on they decided that wasn't good enough, so they now ship with a 2048-bit hard-coded key, and even a 4096-bit hard-coded key, because they're getting better. It's not clear to me, at what point does using kind of wildcard certs for the numbers of addresses across different countries become a real issue? You can't really tell from the outside. It could be okay, depending how you implement it, but maybe it's not. I did see some kind of mega SANs. There was one certificate with 1,500 names in the alternate names fields. And again, the multi-homed hosts are kind of confirmed as, I've talked to some hosters locally in Ireland, and they confirmed that some of the things I see as clusters just are multi-homed hosts. So I'm chatting with people to try and figure out more about what's going on here. I'd love to get more help if anybody's interested or can suggest other causes for this. The mitigations, I guess it's the more interesting thing for the IETF. It seems like the simplest mitigation for the TLS one is just take the model that certbot and Let's Encrypt have of generating a new key every few months, and then all of this just goes away. I guess you could argue that we should build that kind of thing into protocols a bit more. So in MLS this morning, for example, there was discussion of whether to kind of force updates or to say something about updates at a certain frequency. Maybe we want to make sure the frequency cannot be 0 in order to avoid this kind of thing. Measurement, I think, is a good way of doing it. Clearly, if you do measure these, what's going on in the network, you find weird stuff. Like, for example, I found that SSH host key that other people have. In theory, SSH clients could react to seeing the same key in different places and say, that's a bit odd. Did you really mean that? That's not an IETF thing, but it could be done. CAs, I guess, there's not too many of these. A lot of these certificates for the TLS cases here are self-signed certs, a bunch are wildcard certs. A bunch of them, though, are kind of, not too many, but some, I can't remember the number, to be honest, sorry, are real certs with different names in them and the same key. CAs could be a little bit less tolerant of that, I guess, but that would probably be a cab form thing. And it'd be nice if the SSH protocol did provide a way to rotate the host keys, but I guess that's kind of hard and maybe unlikely, but it'd be a nice thing to happen. So that's basically it. The conclusion I had was I was kind of surprised by how often this is happening. You kind of know it's happening, but how often was a surprise. Rotating keys, I think, will help. Measuring can help. This is kind of part of learning to manage crypto at scale that we haven't used before. Measurement seems to work, and if you can explain some of these things, that'd be great, because I have a whole bunch of things that I don't understand about the data set. That's it. Thank you. Any questions?
Daniel Franke. I think if you were to study clients rather than servers, you would end up actually finding some reuse between TLS keys and SSH keys. The reason I predict this is that OpenSSH has PKCS 11 support, but it's rather limited, and in particular doesn't let you switch from the default slot. So if you're trying to use a smart card to just authenticate to everything, it can be sorely tempting to use the same smart card key for an SSH key and a TLS cert. And in fact, I swear I've come across tutorials on how to do this.
Yeah, I mean, yeah. So I think one of the other causes of this is people cutting and pasting, scripts and all sorts of different places.
Wes Hardiker, ISI. So it sounds like you haven't contacted too many people. It sounds like I heard you say you contacted a couple.
Yep. Yeah.
Did you try and make them aware of, especially like the larger clusters, that compromise of one host kind of compromises the entire system, and that,
So I don't do this for a living. I contacted I contacted some of the Irish hosting companies that have some of these things, and I spend a bit of time talking to them. But it's kind of time consuming.
Yeah, it is.
So if anybody's really good at that, I'd be delighted to figure out a way to share some data with you and have you do that. But yeah, I mean, one of the largest cluster in Ireland is it looks like a marketing campaign thing, so it's probably not top of the list. But if you wanted to send those guys a security report of some sort, you have to sign up for some meta service that they use to get those things. And
yeah, no, thanks for doing it. It's fascinating, though.
Mohit, thanks for the presentation. I wonder, there was also a case where people were searching for keys on GitHub, and a lot of open source projects were actually, shipping with actual deployed keys. Is there some way to kind of check whether these keys show? Because now GitHub doesn't allow you to search for ID, RSA, but is there still some way to scrap and see?
DKG, are you going to answer that, or have you a different point? No. Oh, bummer. I don't know. I think yes. I think GitHub have some kind of API or something. Do they? Yeah, I should. I need to go do that. That's a fine thing that I should have done before, but didn't. Sorry. But yeah, that sounds like a useful thing to do too.
Daniel Gilmore. So you didn't find a host of mine that has reused SSH keys with TLS keys just for fun.
Okay.
So your scan is not complete.
My scan is only 10 small countries.
Okay.
Do you live in a small country?
No, I do not recommend doing that, by the way. I'm just saying that there are hosts out there that do reuse across SSH and TLS. I'm thinking about the prospects for trying to minimize this stuff in the future. You mentioned something about certificate authorities being more restrictive. Do you see CT as a mechanism for this? Like, I'm not going to let you get a cert for this key because it's already been used somewhere in CT?
So CT, I kind of use CT as, so when I'm kind of manually trying to validate things, I've used CT and been able to see the same key being used back over time. So like over the last 5 years in some cases. So yeah, you could use it. I haven't kind of programmed up an API to try and do that. But sure, yeah, if you could, I mean, you could check, you could verify in CT that they're using the same key, right? Or the same key is used for different things.
Right.
Yeah, but then what do you do? That's I don't know the right answer.
Reject the application, right? Reject
Oh, sorry, a CA could do that.
Yeah, that's
the
the
good
issuing
idea.
CA.
Yeah.
So if there's any CAs in the room, maybe you want to think about that.
Yeah, that's a good idea. But
yeah, me again. Sorry. First off, Wes, one thing that we had to do in open source software was like deliberately break the config that was distributed, so that it would not boot and would die. And because let's just say the word public was used widely at one point in the past for one protocol as a secret key, not good. The other one you got to look into is DNSSEC, because it actually turns out that there are a ton of DNSSEC signing entities that use the same key for all of their clients, for example. And not necessarily bad, again, because it's at least one key and one control, but it's another common one that you could do more pretty graphs with.
Sure.
Tim Halby, somebody asked if there was a CNA in the room. Unfortunately, if you decide, I would love to not allow issuance of certificates with the same key that was previously used. There's no good reason for it. Unfortunately, if a CA did that, you are suddenly less competitive. So the right way to do it is get a ballot passed at the CA browser forum saying it's not allowed, and then everybody can't do it. I don't think that ballot would pass, but I would love to see somebody propose it.
So I want to be clear, this is DKG again. I was not proposing that you would not allow reuse of the same key for the same entity. I was proposing that you could see whether the key that was being issued had been used for a different entity in the past. There is actually concrete use for reuse of keys in multiple certificates for the same entity going over time, which is key continuity, right? But if you see that the key that's being used has been used for a different entity, that would be the thing that I don't think there would be much controversy about you shutting down. And you could sell it as a security service saying, we're going to let you know that the key you're using may have been reused by someone else.
That second one, notification is actually much easier, just because of the fact that it doesn't actually block their ability to do anything. When you start telling the customer they can't have the certificate that they want to have, then they get upset, unfortunately. And it also actually, if now that I understand your proposal better, that may have a much better chance of passing.
So, I mean, again, I think that the case of different names from browser-trusted certs is there, but not hugely common. The self-signed certs are much more common. If it helped to kind of give some of the data to you guys to help that discussion, I'd be happy to.
Paul Hoffman. So going back to DKG's proposal, instead of saying to somebody who doesn't understand that they're reusing something, that they're running software, you can't do this, and then they will go to somebody who will. Possibly a different thing that would be very useful is either at the time say, it looks like you're doing this is a problem, look into it, or even better, after a scan where there are these things, compare it with a CT log and do a thing saying, look what we found among these things. If you are one of these people, you should know that your current cert maybe isn't what you want, and do that, as compared to stopping somebody at a moment where they're actually trying to secure themselves.
I guess the Jabber scribe, is that a Jabber scribe thing?
Indeed. It's from Yoav, who says, if the CA is using Acme, it can reject the key with bad CSR. That would presumably be followed by the client generating a new key, so it would all be automated. Yeah.
All right, yeah, that's good. So Acme could build in a failure mode that fixes the problem too, actually. That's interesting.
If you're using elliptic curve or any Diffie-Hellman technique, there is a solution to this, and that's just to use the cooperative key generation mechanism that I presented here a few years back. So basically the idea here is, if you've got a device like an IoT thing that you just can't trust it to have enough randomness, the CA does not want to generate a key for that device, but the CA can add some randomness into the mix in a verifiable fashion, such that if the device has chosen a strong key, the device key will be strong. Otherwise, the CA would be able to attack that key, but nobody else would be. So it's not entirely foolproof. There has to be some randomness in the IoT device for it to be completely secure, but it does mitigate it to the extent that you can. You can use that with any elliptic curve, and when I showed it to Kaliski, he's got one for RSA.
Hi there, Benjamin Dam. I'm a bit flabbergasted about the CA conversation because to me that the CA's job is to connect the identity of the key to the identity of the asker, and if the CA is not defending the asker against known keys, then to me it seems like a failure of the CA to do their job. But I understand the perspective. It's just a bit strange to me.
Right. Yeah. Hi, Rich Sauls. I'm a bit confused by the way some of the conversation went. In your study, was it the actual key pair you found reused? So the certs doesn't really matter much, right? It's someone literally, or is it you actually found, or is it the key pair and the cert that were reused?
So every possible thing happens, so, yeah, pretty much, right? So the cases in point, I think, so there's not many cases where it's a browser trusted cert and not a wildcard and is issued to different looking names for no apparent reason and the same key. There are some cases, but there's not a huge number of them. So it's those cases, I guess, is what we're talking about.
Okay, thanks.
Okay, thank you.
We have one more brief talk, which I don't recall. Oh yeah, cyber defense. Oh, you fixed the spelling. That's their point. No, I said defense. Yes, makes sense.
Okay. Hi, my name is Michael Shahowski. I'm from the UK's National Cybersecurity Centre. It's a government department. Which button is it?
Faces forward, so to the right. Theoretically, there you go.
Okay, got it. So we're a UK national government department. We've been in existence since October 2016, so we're relatively new. We've got a program of active cyber defense that we've been working on in the UK over the past 18 months or so. So our remit in the NCSC is to protect UK users and networks from cyber attacks, trying to make the UK safest place to live and work online. So a lot of the work we do is it's defending against the high volume, low sophistication attacks. So the low hanging fruit. So there's plenty of phishing attacks out there in the world. There's spoof email. There's malware that you can detect using DNS records. We offer a web check service for the owners and operators of .gov.uk domains to check the health of their TLS servers, looking for instances of old versions of TLS, old deprecated crypt, problems in their X509 certs. We're looking at tackling BGP hijack. So this is when you advertise routes in BGP that are suspicious. We're looking at some automated analytics for detecting those in advertised BGP tables. And in the telephony world, we're looking at SS7, which is signaling protocol that's been around since the mid-1970s with hardly any change. There are known security problems in SS7. We don't think we can do much about them, but we can offer advice to operators in the UK, and we're monitoring to see how well that advice is being taken up. So a bit more detail. So the takedown of the phishing websites. So yeah, previously, these are websites that are impersonating domains, maybe by changing a letter in the domain name, so that users are fooled into visiting those sites when they believe they're visiting the legitimate site. So we're interested in protecting the UK government brand. So if somebody's advertising themselves to be HM Revenue and Customs, and they're using a variation of the HM Revenue and Customs domain name, then we're spotting those false domain names in registry data, and we've now got an automated takedown service, automated notification service to the individual hosting companies, so that they can take down those phishing websites after doing a manual examination of them themselves. That automated notification process has reduced the time taken to remove phishing websites, down from 45 hours to 7 hours in the case of UK government brands. We're also looking at non.gov.uk phishing websites, but where they are hosted in the UK, and we've detected 120,000 of those over last year, and we've managed to reduce the share of phishing hosted in the UK by our calculations from 5.5% to 2.9%. So we think that's a good win for us. We're looking at stopping spoofed email, where the from address of the email is coming from a .gov.uk domain. So we're doing this by encouraging adoption of DMARC and SPF across .gov.uk domains. So still at a relatively low level, but we have tripled support for DMARC over the past 18 months. As a result, we are now stopping millions of spoofed emails every month from being delivered to users, thanks to DMARC. But we know there's problems with this because there are some messages that are still getting through where we believe that they should be stopped, but they're not. We don't understand why. We're still doing research on that, and when we have the results of that research, we'd like to publish it. So that's a low-hanging fruit. We also tackle the more advanced threats. So the maybe state actors who are trying to get into UK government systems. So over the first 18 months, we've dealt with over 1,000 nationally significant cyber attacks in the UK. And we're going to publish data on those in due course. We're pulling out the root causes of what's behind those attacks, and we'll have some data to bring to the IETF and the global community later on. Part of the point of doing this is to emphasize that, if UK government can be doing this, then other nations could be doing this. They could be offering other systems, similar systems within their own countries, or other sectors. Maybe the financial industry could be offering similar phishing takedown services. So we want to drive adoption of protocols like DMARC so that other people can benefit. We also have a socio-technical research program in the NCSC. So this is about providing, doing the research on the way that users interact with the internet and technology. So a couple of pieces of research work that we've done show that just educating users about don't click on that link if it looks suspicious isn't enough. I mean, yes, you want to do that, but you want to do it in addition to other measures to try and reduce users actually becoming susceptible to those phishing attacks. And realistic password policies as well. We've published advice on how to choose passwords, not saying things like make it 10 characters and mix of alphanumerics and punctuation. People don't do that. They can't remember them. So this is like realistic practical advice about choosing passwords that are appropriate for the system that you want to use. Saying, by all means, write a password down if you need to, because but if you keep it securely and it's done appropriately, then that's perhaps better than some of the alternatives. So go and have a look at our website if you want to see some of this guidance. So why are we here at the IETF? What we want to do is to share some of the research work that we've been producing and encourage others to do the same, to bring it into the IETF so that when people here are designing protocols, they have the information that they need to back up some of the decisions that as to how those protocols will impact on cyber defense. So some statistics on the relative prominence of various cyber attacks, the methods that are used to detect and defend against them, how successful those measures are. We want to do this as systematically as possible across all of the different areas of the IETF, so that whenever new protocol's been designed, the people doing that design have cyber defense at the back of their mind somewhere. They can take it into account when they're doing that protocol design work. We need some industry partners to do this. We're looking for companies that can come and share their research in a venue like this. All doing this so that protocol designers can make their decisions about protocols with the evidence that they need to do their job and to take into account cyber defense. So, questions for the audience here. How are we going to do this? So we've had some thoughts about what we might like, how we could bring this research to the IETF. We thought maybe a new IRTF research group on cyber defense could be the way to go, or a workshop like the ANRW that ran earlier this week. That seemed really good. That would be a way to encourage academia to come and publish their results and make them available to the IETF. Maybe it's sufficient to produce some guidance for the security directorate, so that whenever they're reviewing an RFC for publication, then there's some guidance to them on what they would need to take into account for cyber defense considerations. So we'd like to do this. We've got research that we can contribute to the IETF. We need others to come and help us and do the same, contribute their research, be prepared to put time and effort into perhaps running a group here. So really my plea is to you all, can you come and help us do this? Please come and speak to us afterwards. I'm here with my colleague Kirsty Payne. Kirsty, can you stand up? We're really friendly, so we want to hear your ideas. Thanks. Questions?
Hi, Pete Resnick. I really like the idea of an IRTF research group for this particular kind of activity. And part of the reason is I know, as someone who has implemented in the past and worked on especially the email side of this, a lot of folks won't come publicly to talk about their data because it's commercially sensitive to even mention break-ins like that. If you all are willing to do some of the heavy lifting of convincing those folks to get in the room, an IRTF group can be closed and can have different kinds of models, then everything is open to everybody. And having the data, even if it's not easily identifiable, would be great on the implementer side of things.
Yeah, I know that some companies would be reluctant to bring their data here because it represents their proprietary advantage. As a government department, we're not. We don't have any commercial advantage in this. We are trying to protect UK networks and help a better global ecosystem for internet security, cyber defense. So we need to do that persuasion work with the vendors.
Hi there, Daniel Kahn-Gilmore, ACLU. So thanks for offering to bring more data to the IETF. I think we can definitely use that. I'm not sure what the best route to go within the IETF is in terms of bringing in additional data, but from the motivations that you presented on your slide earlier, I also would be curious to hear from you what other kinds of things the IETF can produce that would help you in your goal of providing guidance to protect people against low-level attacks. So as an example, in the TLS working group, we're in discussions about documents that deprecate TLS 1.0 and 1.1.
Yep.
Do those sorts of documents help you in your goal of increasing the raising the floor? What kinds of things would be useful for you?
Yes, they do. So the web check service that I alluded to briefly. So one of the things we do there is look for those old deprecated versions of TLS in particular, but potentially could be extended to other protocols. So if we have things that are marked as obsolete or not current best practice, then we can use that when we're informing the owners of those services that you're using something that's considered out of date, because we're the experts for the .gov.uk domain. We don't expect all of the individual 5,000 or whatever it is individual domain owners to be able to do that. So we can collate it all in one place, and those obsolescence documents are really helpful for that.
Hi, This is Yoshiro Yonea. So thank you for bringing this topic to the IETF. So my question is, have you talked with other countries' cybersecurity center about this?
So I'm aware that there are other countries that are, have either already created their national cybersecurity centers or are in the process of doing that. Yeah, we would like to talk to international partners. If your country has one that we could open up a dialogue with, I think that'd be very interesting. So yeah, come and talk to me afterwards and give me your details if you'd like to do so.
Hi, my name is Roman Janelu, and to follow up on the last comment, yeah, there's about 90 governments around the world that have national cybersecurity organizations that are peers to yours. I just wanted to thank you again, as others have, for bringing this to the IETF. I think empirically driven OPSEC advice that can be given to protocol design is going to be very helpful. We need to talk about, I think, the structural mechanism to sustain that. Perhaps it's an IRTF group. I think we should discuss more about what the mechanism is, but the general concept is great. Data in the organization into the IETF is great, as is the energy. So thank you.
Great. Thanks for your support.
We're going to cut the line after the guy behind Stephen. You get to talk.
His name could be Stephen as well.
Okay, that's very convincing.
Stephen Farrell. So yeah, again, thanks for this. I think data is useful. The more open, the better. I know not everything can be, but the more, the better that it's open fits this process much better. And then the reason I got up was because Ben forced me to. There's a thing called MapORG, which is a kind of a measurement research group already in the IRTF. Yep. Seems to me like it would be a fine place to start. Bring some work, to bring some contributions to that place, and then if you overwhelm them with detail, then another research group could be spun up, I think, fairly easily. But MapORG seems like a really good fit for the kinds of information you're proposing.
Yeah, we've already identified that MapRG is producing some interesting work that has some intersection with this. So thanks.
This is great. This is Ram Dantu from University of North Texas. Is it possible for you to kind of share or can give some idea about, especially the voice over IP phone calls, spam calls?
Pardon?
Voice over IP spam calls, spam?
Sorry, I don't understand the question.
VoIP spam.
VoIP spam. I'm not sure that we have any statistics on that. So I haven't seen anything that we've published on that. So I don't know.
Yeah, that'll be interesting to see how exactly they manipulate things. Kind of.
Okay, thanks.
All right, yeah, thank you again, and I look forward to seeing more of the stuff in IETF or IRTF. All right. So now we got open mic.
Wow.
Carsten Bormann, this has been communicated enough, but just as a reminder, in case people forget, there will be a side meeting about remote attestation services at 7:15 in the Square Dorchester room next door at, did I say 7:15 tonight? And this is kind of a follow-on to the other attestation meeting on Monday. And this one probably will be focused a little bit more on a testing system health. So if that is interesting to you, see you later.
Yeah, I guess Apostol, I don't know if I'm supposed to be advertising, but you sent also tonight, there's a side meeting on the crypto verification. So yeah, 7:30 in Van Horn, there's also another side meeting with the automated crypto verification protocol stuff. So it's two other conflicting times, but both interesting. All right.
Good.
All right, that's it. Thanks, everybody. And I have the blue sheets up here if anyone still needs to sign. Thank you again to the JavaScribe and Minute Taker.
We'll see you at 3:30. Here, isn't it? Yeah. Here. Call it back. I gotta.